Okay, so does this mean, Jordan, does it mean has the recording started? I think it has.
Yes, it has.
All right, so welcome everybody to the Refactoring 2 session. Normally we would, when in academia, we'd look around and we'd wait for people to show up and so on, but we are driven by our technology, so the recording has started, therefore the session has started. So welcome all of you, and we are going to go through the talks in the order they're printed. So the way they've instructed us to do this is first we have back-to-back with no interruptions the talk for each paper, so there will be the 5-minute talks, and after that you will be able to ask questions. So you may see a chat button. If you want to ask a question, you can, rather than remembering it until after all the talks, you can just start typing it into the chat, and when you do that, please identify either the name of the author or the name of the paper so that we know which paper is you're referring to. It'll probably be obvious from the question, but just in case, if you can make it easier for me to simply read something without having to think too hard, that would be appreciated. All right, so we're going to go through the talks now, and the first talk. Where did my? The first talk is how do I refactor this? Which was given by Anthony Parima, who's helpfully highlighted his name.
All right. So hi, everyone. My name is Anthony, and on behalf of my co-authors, Stephen, Iman, Christian, Mohammed, and Ali, I will be presenting our journal first paper entitled How Do I Refactor This? An Empirical Study on Refactoring Trends and Topics in Stack Overflow. And like I mentioned, this is a journal first publication, and this paper has been published in the Empirical Software Engineering Journal. So most of the prior work in the area of refactoring has been empirical studies on open source systems. However, little is known about the adoption of refactoring activities in practice. For instance, is refactoring just limited to fixing code smells? And I'm sure most of you know, right? Industry projects are complex and they require a more complicated solution. So can developers utilize the concepts that they learn in the classroom or in textbooks on real-world systems? As a research community, we need to know what gaps exist between refactoring as research and its adoption in practice. And to do this, we need to extract the common refactoring intents that align with real-world activities that developers perform. So therefore, in this study, we mine refactoring operations in Stack Overflow to examine the real-world trends and challenges developers face when refactoring their systems. Our work helps the research and tool vendor communities to better support developers in implementing and maintaining software systems. And we have 3 research questions. The first examines the growth of refactoring discussions on Stack Overflow and the technology landscape involved with developers when they refactor their code. The second research question utilizes natural language techniques such as bigrams and topic modeling to present a more granular view of the challenging areas of refactoring that developers require assistance with. And the final research question examines the refactoring topics that are both popular among developers and also the topics that are difficult to answer. With regards to contribution, a tangible outcome from this study is a discussion on how the community can utilize our findings to evolve the field. And we also have a data set that is publicly available and that can be utilized for future studies in this area. Details on how to obtain this data set are available in our paper. All right, so to answer our research questions, we utilize the SO torrent dataset that is currently hosted on Google BigQuery. From this dataset, we extracted the data that is pertinent to our study, such as posts, tags, and so on. We had around 9,000 questions and around 20,000 answers. So next, to answer our research questions, we followed a mixed methods approach where we collected and analyzed both quantitative and qualitative data. Our quantitative approach utilized well-established statistical measures and custom code to report on trends and patterns, while on the other hand, our qualitative approach relied more on a manual examination of the posts. So again, more details about the methodology are available in our paper. So with regards to our findings, our RQ1 findings show that Stack Overflow is a popular venue for developers to seek assistance with refactoring problems, and the number of questions and accepted answers have been increasing yearly. Furthermore, with regards to how, we also noticed that it takes roughly around 15 minutes for a question to receive an answer. And we also observed a rise in questions around dynamically typed languages such as JavaScript and Python. Our RQ2 findings highlight five topics developers seek assistance with when it comes to refactoring, and these are code optimization, tools and IDEs, architecture and design patterns, unit testing, and database. And finally, from research question number 3, we observed that questions on tools and IDEs are not only the most popular with more views than other topics, but these questions are also the most challenging to answer. And on the flip side, the least challenging questions are the ones that are related to code optimization, such as, help with recursion, help with, reducing the volume of a method, and so on and so forth. So those questions are the least challenging to answer, while as the tough questions are questions related to tools and IDEs. So the findings we present in our study can be utilized by multiple groups of individuals to improve code maintenance activities. Our findings can assist the research or academic community in revamping course curriculum to reflect real-world settings, such as refactoring for dynamic languages and refactoring non-source code artifacts. The developer community should look at extending coding standards, especially around naming to other artifacts. And finally, the IDE vendors can invest in improving developer productivity by automatically synchronizing refactorings between project artifacts. And with that, I've come to the end of my presentation. Thank you so much.
Thank you very much. Now, according to my cheat sheet, the presenter of the next paper is not here. Matthew, it's not you, is it? Matthew Nassif? Okay, so in that case, I haven't seen the presenter of the second talk yet. So let's just go on to inferring and applying type changes. That will be the easiest, I think. And we can get back to what's supposed to be the second talk if the presenter shows up. And I think, and Amaya, I think you're
Okay.
mute. There we go. No, you're not.
Yeah. Is there an echo?
I do not.
Okay. Hello everyone. I'm Amit Ketkar. I'm currently working in the programming systems group at Uber, and today I will be presenting our work in and applying type changes, which as a grad student at Oregon State University. So as developers, we're evolving our code to make it more understandable, more efficient, or just to adapt to like new requirements. For example, since Java deprecated some of its classes from the datetime library, I had to perform a type change from simple date form to datetime formatter. Basically, a type change is a transformation where you change the type of the local variable, uh, a field or a method parameter, and then you update the other parts of the code to propagate the constraints of the new type. For instance, here I had added object creation expression to this static call pattern, and then performed another type change from date to local date. So there are several reasons for performing type changes, like library migration, performance, increasing abstraction, introducing concurrency, or just improving the maintainability of the code, and many reasons. At ICSI 2019, we presented T2R, a type migration tool that works in ultra large scale code bases, generates a graph model of the type dependencies across the program. Basically, this tool, or to use this tool, the user has to encode the syntactic transformations required to perform the desired type change. And our tool will perform these type changes over the entire code base like that. However, this is the Achilles heel of our technique, the manual coding part. For this purpose, let's say that you want to create these specifications, you have to maybe co-developer or like look up the API documentation, Stack Overflow, or something like that. Uh, but these specifications could also be inferred by learning from the developers who performed the same change previously in their own code base. So basically, to overcome this problem of having to manually encode these specifications, we produce TC infer. As input, it accepts version history of a Java project. It and each commit in the history uh, and generate the type change rule based on all the type changes that you found in the commit history of the project. Uh, for simplicity, say that it reports a table of type changes found. So, for instance, here you can see that this table has uh, the before type and the after type, and to each row in the table is going to be another table, where in this table each row is rewrite rule. So, for example, you can see that to perform a type change from int to atomic integer, you change the assignment operator to set, or whereas when you perform a type change from file to path, you change the instance method exists to the static method exists. Uh, Along with these rewrite rules are to also collect information like how many projects perform this rule, how many developers, how many commits, and all the real world examples, like the links to the real world example. Uh, the type change rules that inferred by TC can also be used to configure our IntelliJ plugin that performs type change. We call it IntelliTC. IntelliTC operates in three major modes. The classic mode, uh, where the developer basically invokes the refactoring manual. The reactive mode, to overcome the discoverability problem, we track what the developer is doing with the ID and understand if he or she intends to apply a type change, and then we recommend it to the developer. And the inspection, which basically recommend uh, type changes to eliminate misuse. For instance, here you can see that it suggests a change from function integer boolean to int predicate in order to eliminate auto boxing. So, in summary, we propose TC that mines and infers read rules required to perform type changes. We propose TC, a front end for performing these changes learned by TC infer, and our tool and plugin can be found at this website. Thank you.
Okay, thank you for the talk. Now, the next talk is Dr. Async, identifying and visualizing anti-patterns.
Cool. Let me just get a timer. Okay, so hello everybody. I'm Alexi, and I'm going to present our tool, Dr. Async, for identifying and visualizing anti-patterns in asynchronous JavaScript. This is joint work with Mike Shaw, Mark Aldrich, and Frank Tipp at Northeastern, and Mark is at Tufts now. So I'm going to ask you to put yourself in the shoes of a JavaScript programmer that wants to implement functionality to recursively copy a directory. So the first thing you might do is import the file system and path resolution modules using these require import statements. Then you might define a function CP, like an outer function that takes a source and a target, first get some stats on that source, and checks. If it's a directory, we're going to make a function called cpdir and call that. Otherwise, if it's a file, we'll just use the file system's copy file utility here. Then we might define the cpdir function, which, okay, since we're copying a directory, let's make sure that our target directory exists. If it doesn't, we'll create it. And then we'll iterate through all of the files, resolve any paths, and then call that outer CP function. So at this point, you're satisfied. You've implemented recursive directory copying in JavaScript. But you can actually do better than this. If you'll note, here we explicitly use the synchronous APIs of the file system module, and JavaScript is certainly capable of asynchronous programming. There are many ways to do that, but the way that our tool focuses on is the promise-based asynchrony. So I'm just going to quickly overview that. Essentially, a promise in JavaScript is an abstraction around an asynchronous computation. So if we have the synchronous version of lstat, let's say that returns file stats, a stats object. If we use the promise-based version instead, this will give us a promise that file stats will become available. So this would be a promise wrapping a stats object, and this, statting will happen in the background. To actually use this, asynchronous abstraction, one of the ways to do that is using the await keyword, which was introduced in one of the recent ES versions. So here, again, if we had fs.promises.lstat, this returns a promise of stats. If we await that, JavaScript will execute other code while waiting for this to happen. Once the stats are available, they will get unwrapped from that promise and set into the stats variable. The only caveat here is that awaits can only occur in async functions. So if we had a synchronous version of dir exists that returned a Boolean, the async version would instead return a promise of a Boolean. OK, so we revisit our code. Now we write it in the async way. We use the promise-based APIs for doing all of the file system stuff. We make our functions async so that we can have our awaits. And because those functions are async, they now return promises. So we await those too. Now, again, you're satisfied. We have an async version of recursive copying of directory. It's pretty simple. However, you can still do better. The key thing to note here is that the await call in this loop will essentially wait for each call to CP to finish before issuing a subsequent call. To think about this a little bit differently, we can think about the lifetimes of the promises, or the duration of the asynchronous computation that's happening. So CP, this call, let's say this first call to CP, will create a promise. We'll wait for that to execute, and it'll be resolved. The copy will be made available. And only then can we issue subsequent calls to CP, which is needless oversynchronization, because there's nothing inherently synchronous about this. What we would really like to see is many overlapping promise lifetimes, which would be an example of better synchronization, better asynchronization. So this is a pretty simple anti-pattern to fix, and the paper reports on 7 more. But just to give you a flavor for this was a manual refactoring, and this is a real code snippet from App Center CLI. Instead of having that for, we would instead map over files, and instead of awaiting the call to CP, we'll just collect promises together, put them in an array, and then use the promise at all utility, which, if we await that, it will wait for all of those promises to execute. They can happen asynchronously, and then we're truly happy. So this is essentially an overview of our tool, or of the sort of problems we're trying to solve. The paper reports on the visualization tool itself, which visualizes promise lifetimes. They're collected via dynamic profiling. There's 8 anti-patterns, and we report on simple static analysis to detect those. And this problem is very prevalent. There's thousands of instances across 20 or so JavaScript projects. So thank you for your time, and I'll certainly be here to take questions.
Okay. Thank you for that. Now, is anybody here to actually talk about the other paper? There've been 3 talks now out of the 4, and I have been unable to find the tool does tell me who the presenter allegedly is, but the tool does not have a way of actually, physically summoning the presenter who's scheduled to actually show up and present. So we have plenty of time. I guess we can wait. We can still wait to see if this presenter for the other paper shows up. Jordan, I don't think you have found a presenter, have you?
No, as of yet, I have not.
Neither have I. And Jordan is our capable student worker, so we have to assume that there's no such person for now. So let's just start with questions. So for those of you who came later, if you enter questions into the chat for this room, I can read them. If you would rather simply unmute and ask your question, that is probably fine too. Now, I am going to start. Now, I don't see these questions in the chat yet. So what I am going to start by asking questions that struck me while I was listening. And in particular, I'm thinking of questions. If this is for Alexi, you were looking at, you showed this very nice example of, okay, you take this loop and now you had five weights in a row, and now we have all of them overlapped. Now that clearly is good in some sense, right? Things operate at once. But what, if anything, can you do about any interactions through state at this point, right? If let's say one of these, each of these things did something to a piece of state, it may be the case that I have substantially altered the semantics. Do you have, for your patterns, do you capture that, or do you have ideas of what is a good way to figure it out?
Yeah, so great question. In this example, there was no state, but certainly there could be.
Yes.
The refactoring that we performed was manual. I probably should have made it a little bit more clear. This isn't like an automated refactoring tool. So we just highlight these issues, and then we would sort of recommend programmers look at them. There were instances of this kind of await in a loop anti-pattern that we looked at that were stateful and that we could not refactor. But we found that the majority of them that our tool found, or like the majority of the ones we looked at, because we looked at 10 for each of the anti-patterns, but we refactored them manually.
But your tool will suggest here, this might be an anti-pattern, but it does not do checks to say, well, it's actually not an anti-pattern because there's some kind of synchronization that you need anyway.
That's correct. And I will note that the visualization tool, which shows the promised lifetimes, there's a lot more to the viz than just the lifetimes. Like we trace, like, if a promise is chained to another promise, that will show up in the visualization. So there's like some information there to empower programmers to maybe try to see if there's that kind of like dependency between the promises being created, but nothing that like is automatically detected by the static analyses.
Okay, so for the audience, people who have questions, do you want to unmute and ask? Do you want to write them in the chat? I can keep yapping, but I think part of the purpose of this is to audience members to be able to ask questions if they would like.
Maybe a follow-up to your question, I guess, to the answer too. So yeah, you hint at places where it might be a not efficient use of synchronicity. Maybe you should turn that. Is it correlated to test smells, or do you plan to eventually go towards a more automated refactoring? I'm not sure, where this work is really going, or is it just really on both sides?
So this was in JavaScript, and certainly one of the limitations of program analysis in a dynamic language like JavaScript is you never really get a good sense for what the program is doing. So for like this synchronicity thing, like the example that Julian highlighted, where there might be statefulness, that might be a little bit hard to detect. Certainly some of the other anti-patterns are a little simpler, and those could be automatically refactored. This is something we're thinking about. I think it would be really interesting to see how well you could automatically refactor these. But that's like future work for sure.
So do all your anti-patterns involve async or not?
Yes, well, they all involve promises. Some of them are related to async await, and others are related to like promise, like reactions and things like that. Like redundant calls to like then, or redundant promise creation, that sort of stuff, that sort of thing.
Okay, Because one thing that always, whenever I have to do asynchronous programming in JavaScript, one thing that always tends to drive me nuts is the whole process of making something async. You basically lose the structure of your backtrace doesn't really work anymore. And so if you like to use the back traces for debugging, you like just like to look at the stack trace and see where am I in my program, you kind of lose that. Do you have anti-patterns around that sort of thing?
No, but that's really interesting. And if you're going to the in-person conference, maybe we should talk about that, because that would be really cool.
I am actually going to be at the in-person conference, and yes, because I occasionally have to use JavaScript, if there was someone who could essentially give me a backtrace for async, that would be extremely cool.
Yep, I agree.
So now I'm going to once again try prod the audience gently. If you would like to either type a question or if you would like to just unmute and say it, that's completely fine as well.
I have a question if I'm allowed to.
Yes, you are. And please say who it's for.
It's the first author on the first paper. I don't remember the name, but the first person who presented.
Anthony, I think.
So yeah, Anthony.
Yeah.
So Anthony, good work. It's kind of interesting, especially given the importance of refactoring. So the question is related to one of the things that you said, that the questions related to the tools or IDEs were more difficult, but wherever the developers were asking or having questions related to refactoring plus any other quality aspect, they were relatively easy, which goes kind of against the folklore or what we assume or what we understand so far. The tools related questions are typically straightforward, or just say that this is how we use it. And wherever the refactoring or the maintainability is infringing with other quality aspects, they are typically difficult to answer. So it is going against that thought. So would you like to comment on that?
Sure. So one reason we noticed was that most of these questions that developers were asking around tools they were trying to do refactorings that were a bit complicated, that weren't straightforward, that you couldn't do straightforward with a tool. Like, for example, it's not like a simple rename refactoring. They wanted to do renames plus design level changes and stuff, which the tool which like the IDEs don't have that built in. So those questions weren't getting an accepted answer. They were getting responses, but they weren't getting an accepted answer. And also another issue that developers were complaining about was with renames. They wanted to do bulk rename, not just a rename in, like, normally when we do a rename in the editor, we go refactor rename and it just renames all instances in the source code, right? But here they wanted to do renames across multiple artifacts. Like you have a SQL script. So for example, they wanted to change something in the model, and they want that to propagate to the SQL, to the database schema and the database layer and so on. That wasn't something that the tools, IDEs and tools are capable of doing. And along those lines, not just rename, but just general synchronizations of refactoring, refactoring the production code and synchronize the changes to the unit test files. Those were the types of questions that weren't getting accepted answers. But the other stuff, like general code stuff, like shrink this long method, or how can I replace switch statements with something more simple, those were getting responses a lot.
Understood. Thank you.
So if I could, I think somewhat related thought, which is that one of the trends over the years in Java has been this addition of constructs that seem more functional, right? This notion like like loops becoming streams and things like that. Do you find questions about do you find people asking questions about how do I modernize my code in some sense? How do I take my code and go from a for loop to a stream or something like that? Do you find those questions, and do they get answered well?
Yes, there were questions on legacy code. A lot of questions were regarding legacy code, refactoring of legacy code. There are instances where people were saying, hey, you know what, I've been put into this project and I'm supposed to be maintaining a system that's like 5-10 years old. How do I refactor it without breaking it and stuff like that? So legacy code, yes, there were a lot of questions around legacy code, and they were getting responses. They did. I can't remember what exactly the theme of those responses were, but legacy code was in fact one of the reasons. In fact, when I was mentioning that we did NLP techniques like bigrams and so on, legacy code was one of the top hits, frequent terms when we're doing bigram analysis. So yes, legacy code, refactoring of legacy code is one instance where developers seek assistance with.
And how about, do you find people somebody maybe picked up a design patterns book and read it and thought, my code ought to use a visitor, or my code ought to use a this or that, and they ask questions? Do you find questions about basically how do I apply the design patterns book to my code?
Yes. So again, like when we did the topic modeling exercise, one topic was on design, and they were mostly around design principles like case, DRY, and solid, and things like that. So the main theme around it was around reusability. So what we noticed was like the two key concerns was reusability and readability. How can we improve reusability and readability in our code? So those were like the two main themes that stretched across different topics, like code optimization, design improvements, and things like that.
I can ask one more question to the same author. So it is related with the usage or the frequency of usage of refactoring techniques. So earlier studies, like in 2010, around 2010, Emerson Murphy and many other authors, they did research on the usage, the frequency of refactoring techniques, and they found that most of the developers were using rename mostly, and maybe some couple of more here and there. But majority of the refactoring techniques that, for example, Eclipse or JetBrains or IDEA, JetBrains IDEA, IntelliJ IDEA provides, they are not really using them. So do you still think that this trend is continuing, or do you think the trend is changing?
In terms of renames, like some of the studies, not this study, but my dissertation is based on renames. So there is a lot of work that's being done on rename refactoring, because we use the tool. I'm sure Amaya can testify to that as well. We use Centellis's tool on refactoring miner, and renames were one of the main causes of refactoring, and then change types as well, right? That also was another major cause for refactoring. So yes, renames, change types, those are like one of the two common refactorings that developers still perform. They still have problems with figuring out what is a high quality name and so on. And just to go on a tangent, that's like segue. If you're attending the in-person ITSE, my advisor is giving a birds of a feather talk on identifier naming and stuff like that. So if you're attending, feel free to attend that talk as well.
Thank you.
Okay, are there other audience members who would like to ask questions? And I seem to not see anything on the chat. I wonder if I'm even in the right.
I think you're in the right place. I don't see anything either. Yes?
Alexi,
Okay.
I have a question for you. So, can you hear me?
We can hear you, Amaya.
Okay, yeah, I think this is better. So when you do this refactoring that you showed us right now, will the program require more runtime memory? Because now you've stacked up all the awaits.
That is a good point.
Like, I'm just thinking from a mobile app perspective. Maybe someone has done that or whatever. Like someone is doing that just to save memory.
So that's an interesting question. We have not considered the memory footprint in that sense. I think the memory footprint of promises is fairly small. And especially in that particular refactoring, it's not like the call to CPU is returning anything. But that is actually like a really good point. I think that would be an interesting angle to explore in the future. I'll just like take this opportunity to say that some of the other refactorings would actually serve to reduce the runtime memory, because there's many instances where like redundant promises are created, and that saves like a lot of yeah. But great question. Yeah, thanks.
And in general, right, this trade-off is something that's got nothing specifically to do with promises. It's very much inherent in when you try to parallelize code, right? If you have multiple things running at once, you need the memory for all of them at the same time.
Yeah.
It's a bit, I mean, I've done work over many years in parallelization, and that's always an issue. The question is, do you have, when you want to overlap things, what the usual thing is that two things have two pieces of state, and that causes trouble. And the other is they both create copies of something, and so you end up needing more memory overall.
Yeah, I think one way to work that memory thing into the current tool that we have would be to add like a memory profiler to the promise lifetime visualization tool. Like have like another tab to see like what the memory footprint would be. I think that'd be pretty cool.
Okay, people should feel free to pipe up if they would like. Now, I'm going to ask Amaya a question, which is, looking at your tool, you were looking at these examples of refactoring, like atomic long or int, or I forget which it was now, and from int. Do you think now for a language like, you can see why that's useful? And one question I have is, that's for Java. Would you care to speculate on how this sort of thing would apply in more dynamic languages? Do you think that you really rely completely on static type information that's available, or is there analysis that could help? What do you think?
We can rely on like some type inference and things like that, but as a tool, you know how we developed it is like, it's like a theme that we're doing, but it's like a type change. Like basically, it's just going to look up the references, and at those references, it's going to
Sorry,
try and
Amaya,
apply the rewrite rules.
Sorry, one moment. Amaya, sorry, is anyone else having trouble hearing him? I found your voice breaking up a little bit. Could you maybe you could?
Is it better
on your end, Amaya? Oh, sorry. Go ahead.
And now you're muted. You are muted, Amaya. And now it's better. Yes, I would say, even though I'm the chair, I don't think I can unmute you myself.
Yeah, basically, I think even for dynamically typed languages, you would at some level perform a type change, and to perform that type change, you would want to update the API of it, like wherever it is referred. And I think in those places, you can just go and apply this tool also. Okay, it is not going to be very good at inferring it, because you require some static type analysis to figure out what variable is linked where, or like referred where. But you could come up with a approximate refactoring which does all the dirty work, maybe.
Yeah, I'm just wondering, are you familiar with people who, do you know of any people doing similar things in dynamic languages?
No.
Well, even IntelliJ does support some dynamic languages.
IntelliJ doesn't support like these type changes in these dynamic languages, I doubt.
Sure.
Like IntelliJ or Python, I mean the Python IDE. I think the IntelliJ IDE itself has like some basic support, and this is like the new plugin that I developed with those folks.
Okay.
I have a mini follow-up. This is coming from somebody that this isn't really like my area, so this question might be ludicrous. But how? So maybe IntelliJ doesn't work so well with dynamic languages. But what about like TypeScript? So like an optionally typed language.
So there are like two parts in doing the type change problem. One is like figuring out these specifications. So basically, if
Yeah.
I want to perform a type change, how would I go and adapt the references? And the second part is actually, if I want to update this variable, what are all the places which I would want to adapt? So I think the second part varies on how good your type inference is, or how good can you basically figure out those references. And on this inference part, I think it is very statistical and syntactic. Basically, I just see, is there a variable whose type was changed, and then I look up its scope and see how its references were adapted across the commit, and then I just learn like a rule based on that. So I think the learning rules should not be a problem. Just applying these rules would be a problem in these non-static languages.
Yeah, checks out. Thanks.
But I guess this problem is more difficult if we decide that we want to do these changes for like Rust or something, because there now you have to think about, borrowing the borrow checker, and uh, is this replacement API still satisfying that borrow checker or something like that? So
Oh, that's so interesting. It's like you would think that more types would make this kind of thing easier, but yeah, that's really a good point. Like Rust would actually
if
make
you
it harder.
so Java C# is like that perfect place where you can apply these techniques.
Yeah.
If you go like dependent type, then this won't work at all.
I think a lot of this work has been done in Java. Java has been a nice playground for this sort of work, just because it is, as you said, it's very. But I suppose with these optional languages like TypeScript, you would end up with trying to do a refactoring, and maybe somebody hasn't specified some of the types, and you could even imagine the tool saying, do I think that it's likely to have got there or not? Is there anything I might need to change? If not, probably I'm fine. But maybe there is. You could imagine a host of warnings to say, I think I know what you meant, and I think I did it right, but it's all optional. So seriously, I don't actually know.
So if I can chime in, so in the study that I did, we noticed that there is a rise in developers asking questions around dynamically typed languages like JavaScript and Python, right? So this shows that they are struggling with refactoring such types of code, right? Maybe what's taught in the classroom is more focused, is Java heavy, right? So once they go into the real world and start joining startups and have to work with different JavaScript frameworks, they're struggling. Okay, how can I implement this extract method or type change that I learned in Java in JavaScript, right? So that's another observation that we noticed, and it also shows that the IDEs, tool vendors like, for example, JetBrains and so on, might want to invest a bit more on refactoring, providing more refactoring support for dynamically typed languages.
Yeah, actually, so that's interesting. So the Stack Overflow, so if you're looking at the questions and answers, when you say more of the 5 dynamic languages, it makes sense. Do you find answers, people suggesting tools for dynamic languages, refactoring dynamic languages, that actually work? Do you find people say, oh, there's basically nothing works anyway, so you all have to do it by hand? Or does someone say, well, I plugged it, I don't know, say IntelliJ or something like that, some tool, or whatever it is, some tool that actually does something for a dynamic language, PyCharm or whatever?
Now, in the samples that we manually analyzed, we did not see anyone, recommending a tool to refactor, JavaScript or any dynamically typed languages. Tools are more recommended for like, the regular, statically typed languages.
So clearly, if someone is looking for a research topic, then it seems to be there'd be a wide open space here. Probably, it's certainly a harder problem.
Well, that's the thing, right? I mean, I like the Dr. Async is like for JavaScript, and I've done a little bit of other work on other refactoring tools for JavaScript, and like, yeah, I don't know, just the analysis you require to suggest useful refactorings that you have a high confidence actually will work is like not super possible. currently, I think, especially at scale. Certainly on small examples, yeah, but if you want to refactor a whole project.
And it's
really
probably part of the reason why when I was asking about interference between state and things, doing an analysis of that in JavaScript would be, I mean, in Java, you could imagine a conservative analysis, right, that might be able to do something. In JavaScript, you often have, it might well be substantially more challenging.
Yeah. But, you know, hey, challenges are fun, right? We don't shy away from those. So.
Well, no, I mean, we obviously, I mean, students don't need to and stuff, so that there's lots of time to work on it. Now, let me prod the audience again. My display doesn't actually even tell me how big the audience is, so I have no idea how many questions to expect even. But does anybody would like to ask? Ooh. But you know what? I see people's names down here at the bottom of the display. Maybe we could do be like an annoying high school teacher and call on somebody. No, we're not going to do that. Don't worry, we're not going to do that. Let's see. So are there more questions? It's already 12. It's for me it's 12:46. For you it's whatever time it is.
I have, maybe a long shot question. I hesitated before asking it, but there's Amelia's work on type changes, and then Alex's work seems to change the type of JavaScript programs. Might there be some correlations maybe to automate some of these changes, or so I guess my question would be more to Amelia. Do you think that your approach might help change the type to promises, which it's not only about changing a type, but also changing the sort of nature of the computation?
So the thing is that my tool doesn't check for like these domain specific preconditions that you would have to perform a type change. So I would assume that a more Java version of this async thing would be that moving from hash map to a concurrent hash map or something like that. But to do this, you need to do like more domain specific analysis to understand like domain of these types, like hash map versus concurrent hash map, in order to actually know if even applying that change makes sense. Like the tool itself can just go and syntactically update the code, right? Like, and it can check whether the code compiles after doing all of this. If it does, it will be like, yeah, but does it make sense to do that change? Maybe not. Like, I think for that we need like more Dr. Async kind of approaches. Though I think Dr. Async is also kind of suggesting a type change, but it's somewhere like at a higher order in the language itself, because you're suggesting that now add this async keyword and await keyword. I'm not sure.
No. I think in Java there's not, a hard-coded asynchronous facilities like promises.
Mhm.
But still, when you suggest a change, I guess you answered, but would there be a way to go around these limitations where you actually have constraints related to the type that you need to know about? So yeah, also I had in mind the hash map versus concurrent hash map. When you use these, you need to be careful about the threads you're using, and I guess like I said, it's not fully fleshed out in my mind, but yeah, would there be a way to add these requirements to your type changes suggestions?
You can do that. Like you can hard code these kinds of things into the type change tool as preconditions. So like, for example, if you want to do a type change from list to set, which is very difficult, right? Like changing list to sets, because you need to reason about a lot of properties. But you can maybe come up with some analysis to figure out that is the ordering of the iteration does it matter in like the overall function or something like that, and figure out whether a list could be changed to set, and then syntactically just update the code. Like updating the code is something that my tool learns, but when to do that is it's a very difficult question. Like it's something very difficult to do, I think.
Yeah.
The only thing that helps me like is the type system. If the code compiles, I'm happy. But yeah.
Yeah. Okay. Thanks.
Actually, no. I wonder now, Alexei, you looking at the Java, looking at the JavaScript promises. There are a bunch of analogous libraries or these APIs in Java which use effectively promise-like things. Often Eclipse has one built in, I know, and some of the other like the language server protocol library does as well. Do you think something similar would be useful for finding anti-patterns in the sort of code that uses those, like code inside the Eclipse GUI, for instance?
Surely, yeah. I think so. I can't see why not. As like a lot of the, I think so. Maybe the anti-patterns would look a little bit different, depending on just the specifics of how like these things are implemented and how they interact together. But I think it would certainly be possible.
And I wonder, what about Python? I think Python, increasingly people like to write asynchronous code of one sort and another.
I'd have to look into what the asynchronous programming model is in Python. I've been looking on projects, so maybe I'll do that. But that does sound cool. I'll maybe mention also that I think the cool thing about doing this in Java would be analysis of Java is probably a lot more information there than analysis for JavaScript. So you could probably, maybe Java would be a great place for automated refactorings for these anti-patterns. Yeah, cool.
You actually take that loop body and transform the return to return an async and put it and then wrap it all in a promise.all.
Yep.
Yeah, that makes sense. I've written code like that in Java. I guess it would make sense. All right, let me try to gently prod audience members again if anyone has had questions. And as I said, I haven't seen anything in the chat. Possibly I'm not finding the right chat, but I don't think there is. All right, we're getting close to the end of the time anyway. But and I guess there's still no sign of the speaker for the other talk, is there?
Happened a few times. I think some people also forget that there's like that even though there's two presentations, they have to go to both of them. Or maybe they forgot.
Yes, and one of them is usually at a thoroughly inconvenient time, I believe. Okay, well, we've managed to use up most of the time anyway. We just have a few minutes, and it should be probably useful for other people who have to go to a session immediately next to get a couple of minutes to figure out where they need to go and figure out how to use midspace to get there. Of course, if you do think of questions later for our speakers, you can obviously contact them on chat, or if any of you are going to ICSI in person, which of course is highly recommended, you can probably find them there as well. And so in the meantime, I'd just like to thank all three of our presenters. It's a bit of a challenge to somehow to cram everything you want to say into 5 minutes, and so that was thank you for doing that, and thank you all of you for attending. So I think unless anyone else has other questions, I think that's really about all we have for now. I don't know. Have people been applauding, by the way, in previous sessions? Have you heard it anywhere?
No, not really. Sometimes you just do this. There's like a little emoji you can make float that's like applause. So that's
So
what I've
maybe
seen.
what we should do is let's try to experiment. Everybody, how about if everybody unmutes and then tries to clap? Can we do that?
Thanks, everybody. It was fun.
All right.
Thanks,
Thank you.
everybody.
Thank you very